Good day, Professor. My name is Said, and today, together with my team, we will be presenting research paper published by the philosopher Susan Schneider called "How to Catch an AI Zombie: Testing for Consciousness in Machines." Um, our presentation is divided into four parts. I will start with why machine consciousness matters at all. Below, then we'll walk you through Schneider's main test, the ACT. The ACT. After that, Butterbeck will cover two more tests, integrate information theory and the chip test. And Shahrior will finish with Schneider's precautionary stance plus our own critique of the paper. So, before we start, we should answer the following question. What do we even mean when we say consciousness? Schneider keeps it simple. Consciousness is a basic fact that it feels like something to be you. For example, the cause of a sunrise, the smell and taste of your morning coffee, that sensation that you feel when you touch your own hand, this first person experience that you have every single moment of your life. Her clever move is that we don't need a finished scientific definition to start testing for it actually. Instead, she treats it like a diagnosing an illness. No single test is decisive, so we use several markers and cross-check them. Those tests are ACT, Integrate Information Theory, and the chip test. Now, why should we care about them? Schneider gives 5 reasons to start building this test today, even before AI is plausibly conscious. First, the nature of mind. The most powerful intelligence in the universe might actually be brilliant but completely non-conscious, meaning intelligence and inner experience don't have to go together. Second is moral status. If an AI can suffer, using it carelessly becomes an ethical problem. Third is a human-machine merger, which we will discuss a little bit in more details later. Fourth is the risk of being replaced. And fifth, AI safety itself. Let me make reasons 3 and 4 a little bit more concrete. Just imagine that it's 2060. You have a brain tumor. I wish you don't, but if you do, imagine that you only have months to live. Surgeons offer to replace your brain chip by chip with an artificial one. But here's the catch. If silicon can host consciousness, as we discussed in second reason, you don't survive that surgery. You become a non-conscious copy of yourself, which we can call an AI zombie. Now, to scale that up, thinkers like Hawking and Boston and uh, Elon Musk warned we could lose control of superintelligence. Schneider points is that it's even more tragic if whatever replaces us has no inner life at all. No one left after us to actually experience the world. And consciousness could cut both ways for safety. It might make an AI more empathetic or more volatile, like HAL 9000. Either way, we can't know without a test. So, and that's exactly what Bilal will show us now.
For my part, I'm going to talk about the AI consciousness or the ACT. As AI gets smarter, we face a big question: is the machine actually uh, feeling and experiencing things, or is just acting like what it is? The ACT is test designed to look at an AI behavior it's to figure that out. Schneider's main proposal is AI cautiousness or ACT. You might so why not look under the hood? Next slide, please. You might think we could just look inside and read the AI's code, but that fails for three reasons. First, the black box problem. Even today, engineers cannot fully explain why deep learning um, systems do what they do. Second one, an AI has a brainstorm. None of the biological structures we link to consciousness, so there is nothing to compare against. And third, architecture keeps morphing. Its design can change faster than any human can follow. So the test has to work from the outside, from behavior. Next slide, please. The core insight. Here is a clear idea. Only conscious being can easily imagine consciousness-based scenarios because it feels like something to be us. We can picture swapping bodies, reincarnation, and out-of-body experience. Think of the film Freaky Friday, where mother and daughter switch their bodies. We find it imaginable because we can picture our own brain. A system with no inner file, no inner life would struggle with that, like asking someone deaf from birth to appreciate. So what an ACT asks? So the ACT asks a series of increasingly demanding its hardware. How does it handle body switching or reincarnation? Does it prefer good experience in the future rather than the past? Even though in the future laws of physics are time symmetric and give no reason to uh, passing any one of these enough. So boxing in. But there is a loophole. A clever non-conscious AI could just read about neuroscience online and fake the right answer. Schneider's is to fix box it in, cut it off from the internet and from any writing about consciousness, while still letting it use language. It never learned or concept of consciousness, then spontaneously describing an inner life becomes real evidence. Remember IBM's Watson, who used like belief fluently on Jeopardy, yet nobody thought it it was conscious. So strengths and limits. So now one more. Finally, the strengths and limits. A Siemens robot, Elvex reporting that dreamed or Hall pleading not to be switched off. This convey in a life through what's said, not how the machine looks. Uh, not machine how looks. Passing the ACT is sufficient evidence of consciousness. It filters out the zombies, but and this is important, failing it proves nothing. An infant or animal couldn't pass the language test either. The ACT is built on our human idea of consciousness, so genuinely alien minds might slip right through. So next person will continue.
Good day, Professor. My name is Rotbaev Paterbek, and I'll be continuing the next sections. So, I'll be continuing with the provisional framework, and it's regarding the first one is regarding cautions and the K distinction. So there, Schneider says that there are two most important types of consciousness. The first one is phenomenal consciousness, and the second one is cognitive consciousness. So, what is phenomenal consciousness? It's like being alive, feeling the feeling of being you to be you. So, like for example, when you can smell the smell of the coffee, when you can see the color, for example, the red color, or when you can feel the pain or be happy. That is what's called the phenomenal consciousness. And the second one, which is cognitive consciousness, is really different from it. It's more about more about mental abilities, for example, like learning, reading, calculating something, for example. So the AI has all these abilities, but at the same time, he might not have the ability to feel anything. So Schneider saying that if the AI has a cognitive consciousness but don't have phenomenal consciousness, it means that it's called an AI zombie. Also, it behaves intelligently, but there will be no inner experience in it in their AI if there is no phenomenal consciousness. So the main point of this section is that intelligence is not same as the consciousness. There is a difference. And so the next one is about integrated information theory. So what is the idea here? So the main idea is that actually the integrated information theory is that it introduces when the consciousness depends on how the inner system works. So it was developed by the neuroscientists Tanoni, and the measurement of it is valued by the letter phi, the Greek letter, and if the parts of the brain are like working together closely, it means that there is a higher phi, and if the phi is higher, it means that there is a higher chance that the AI have consciousness. One piece of evidence, for example, the cerebellum that is in brain. The scientists say that it has very low phi, but people with cerebellum are living a normal consciousness life. So Schneider saying that IIT also is attractive because it can look to the inner system rather than ACT. For example, ACT only looks to the behavior, but the IIT can look also to the inner structure of the system. So it can be applied both to biological brain and both to artificial brain. And the next is about, does high phi mean consciousness? Let's talk about it. How the Schneider says that it's not fully correct because the phi cannot always calculate the huge systems like the brain of human being. Also, computer scientist Scott Arons showed that the two-dimensional computer has a very, very high phi. And Tanoni says that if the phi is high, it means it might also be, there is a possibility that it is more conscious than the human being. But Schneider is not fully agree with that. He's saying that it sounds ridiculous and most people do not believe it, because how computer can AI can be more cautious than the human being, even if for example the phi is higher. So it does not necessarily mean that it's more cautious than the human being. So Schneider says that if the fee is higher, it does not necessarily prove that it's more conscious than the human being. And the next about is chip test. The chip test. So the final test is this is a thought experiment about replacing human brain with a chip, with a computer chip. For example, if there is a surgery, one person having a surgery, brain surgery, doctor is replacing his some part of the brain with computer chips. And after the surgery, the doctor will ask the person, and the person answers like, if everything is same as it was before when the chip was not put in his brain. And if he answers like if everything is same, like the inner experience, the consciousness experience, if everything is same, it means that the chip may be applied to the brain and support the consciousness. But on the other hand, if the person says that he's feeling some losses, for example, the loss of some experience consciousness, it means that the chip does not really support the consciousness in the brain. And also, the deeper question is whether silicon chip can truly support consciousness, or whether consciousness depends only on biological issue. And the next question is about why the chip test matters. So the first main reason is that it helps identifying which materials might be capable of supporting consciousness in the brain. And the second of it is certain type of chips that works in humans in the AI system that work. If a certain type of chip works like in humans' brain, the AI should built with the AI that was built with the same technology should be examined in the same way. And the third one is regarding the IIT and SAT. The chip test can detect forms of consciousness that the SAT might not able to see and miss it. For example, an animal may have like conscious experience, but cannot answer to philosophical questions. So similarly, an AI with a non-linguistic form of consciousness could fail like the ACT, but still pass a test of the chip test, because if like he doesn't have linguistic abilities, it does not necessarily mean that it can like pass the ICT, but it can pass the chip test. So in overall, like ICT is for looking for test the behavior, and the IIT looks to the inner system, and the chip test is if artificial hardware can support the consciousness. These are the main three tests that we have to test the consciousness. And that's overall about these three parts.
All right, this is part 4, and here we change the direction a bit. The earlier parts showed you how Schneider tries to test for machine consciousness. Now, what I'll do now is cover her final argument, the precautionary principle, then her summary, and after that, I'll give you our take, where we think she's right, where we push back, and what all of this actually means for us as engineers. Let's get started. Schneider closes the chapter with a pretty simple idea: better safe than sorry. The precautionary principle says that even a technology could cause catastrophic harm, and the science is still uncertain. The burden shifts onto the developers, then have to show it's safe before pushing ahead, not the other way around. And she backs this with history in in 1854, and a doctor in London stopped a cholera outbreak just by removing the handle of one water pump. The evidence was weak at the time, but the cautious move worked. Same story with asbestos. If people had listened to the early warnings instead of waiting for certainty, a lot of lives would have been saved. From that, she gives three recommendations. One, make consciousness testing a normal part of building advanced AI. Two, if a system is conscious, give it the same legal protections we would give any other sentient being. And three, the boldest one, even if we are just unsure but have no reason to suspect consciousness, we should treat it as a conscious anyway. Conscious is anyway. When in doubt, error on the side of care. Um, Summary of the paper. Her big picture summary is this: no single test settles the question. So instead of hunting for one perfect test, you use several markers together. Across the checks them and refine over time. The quickest way to remember the whole paper is three pieces. Why it matters. Consciousness is what decides whether something is someone with a moral status, and it's tied to existential risk. The toolkit three tests. The ACT looks at behavior. AIT looks at information structure. The chip test looks at the physical substrate, and they are complementary, not rivals. And the stands take this seriously now and treat any AI we suspect might be conscious with special care. All right, that's Schneider. Now here is where our group landed. Starting with that, we think she gets right. First, testing beats waiting. Refusing to sit around for some perfect final definition of consciousness is honestly the scientifically honest move. We can study the markers we have now. Second, the humility is built right in. She treats every test is as fallible and across checks them, which is exactly how real medical diagnosis works. No overclaiming, and we really like the boxing in idea, cutting the AI off from any prior knowledge of consciousness is a genuinely clever way to tell a real report apart from mimicry. But we don't buy all of it. A few pushbacks. The biggest one, boxing in just isn't realistic anymore. Today's models are trained on basically on the entire internet, so you cannot unteach a language model the concept of consciousness. That means the act may be untestable in practice. Next, the classic other minds problem. Behavior can't actually prove the testing. Prove a feeling. A good enough mimic passes the test without feeling a thing. Sort all three tests quietly assume consciousness looks like ours. So a truly alien machine mind could be missed entirely. And finally, IIT itself is contested. Many scientists call it unfalsifiable, so leaning on it's risky. So what we actually do with all this, a few takeaways. Apply to today's chatbots when someone insists their AI has feelings. Schneider's frameworks explains exactly why fluent talk isn't evidence and why boxing is now nearly impossible. As a search recommendation, we think consciousness checks should be built into AI safety pipelines. The same way we already red team models for capability and bias. The lesson we took: intelligence is not the same as consciousness. Engineers should assume a smarter system is someone, but they shouldn't assume it isn't either. And we will leave you with the open questions. We can never be fully certain how much moral caution is too much. Where do we draw the line? To wrap up, Schneider gives us no certainty, and that's actually the whole point. We may never definitely prove a machine is conscious, but we can build a fallible across checked markers. They act IIT and the chip test and act carefully on what they tell us. Our take is it's valuable, honest first step, but the behavioral test can't escape the other mind's problem. And boxing in is fast becoming impossible. And boxing, so the safest path is humility plus precaution. Assume care wherever doubt remains. And if you remember one line from all of this, let it be this: intelligence and consciousness are not the same thing, and that difference carries real existential and moral weight. Thank you.